Hello, everyone. Thank you for tuning in to listen to my online presentation on Chasing Swamps, Building a Research Site Inventory and Long-Term Monitoring Project of Forested Wetlands in Kespukwitk, or Southwest Nova Scotia. My name is Chad Simmons, and I am an ecologist with the Mersey Tobeatic Research Institute. You've no doubt heard about wetlands before, but what exactly is a forested wetland, and how is it different from others? Well, on top of being difficult to capture, as you can see here from the photograph I've taken, they are wetlands, and wetlands are, of course, wet ecosystems. Within the Environment Act, they are defined as having a water table either permanently or periodically at, near, or above the land's surface, or they are completely saturated with water and sustain aquatic processes as indicated by the presence of poorly drained soils, hydrophytic vegetation, and biological activities adapted to these wet conditions. So now that we've established wetlands are wet, we can define forested wetlands as woody wetlands. They are defined as wetlands with 30% or more cover of woody species greater than 2 meters tall. So this would be our tall shrubs and trees, and they can include treed tall shrub swamps, shrubby treed peatlands, and of course associated vernal pools that are also forested. Forested wetlands occur in complex ecosystems that are often continuous with other wetland types, resulting in an overlap with other ecosystems. However, forested wetlands often contain unique species assemblages, and their conservation faces distinct challenges around pressures, mapping, and policy. So before digging into the nitty-gritty details of the project that I'm here to present to you on today, I wanted to paint the picture of where our work has come from and describe the group that is hard at work conserving Kespukwitk. So this is the KCC, or the Kespukwitk Conservation Collaborative, and it's a collection of partners focused on coordinating conservation efforts in Kespukwitk. One of MTRI's ecosystem targets in southwest Nova Scotia is the forested wetlands target that I help manage, but we also work on the forest target and the riparian target. The forested wetlands KCC target started in 2018 with the initial conservation planning process to gather information from experts. Then, from 2018 into 2020, the meeting focused on follow-up work and implementation, specifically on establishing a follow-up group, reviewing policy, and a synergies workshop. In the winter of 2021, we held 2 virtual workshops to reconfirm understanding of the conservation context and status of forested wetlands and species at risk that they support. And we also worked to identify and prioritize effective strategies or actions for their conservation. Finally, just last fall and winter in 2021 and 2022, we had 2 meetings to develop key ecological attributes for the forested wetlands target. So all of this previous work has really led us into the 2 projects that MTRI is help managing today. And this is going to be the focus of the rest of my presentation. The first is establishing a forested wetlands research site inventory, and the other is to design and implement a long-term monitoring program for forested wetlands in Kespukwitk. Both of these projects were born out of clear needs heard from the KCC Forested Wetland Group, namely that researchers face barriers finding forested wetland sites appropriate to their needs, and with growing pressures from invasive species, climate change, and other factors, how are forested wetlands changing? Now, our site inventory is exactly what it sounds like. It's a list of forested wetland sites in southwest Nova Scotia with details about what the sites are like. The long-term monitoring program is also fairly self-explanatory. We want to have a program monitoring how these ecosystems are changing, which is a critical step in conserving them and potentially mitigating impacts on these ecosystems from human activities. Our research site inventory has evolved a few times since it was brainstormed, and now it includes several goals. Its main goal is to encourage research into forested wetlands in southwest Nova Scotia by allowing researchers to find sites efficiently and effectively. So it's quite hard to know what projects the inventory could help support, so we wanted to cast a wide net when it came to selecting sites and have several sources of site information. So the first main way that we're going to collect information is we want to collect site information from other researchers, with their permission, of course, to add to our inventory. The second is to sample our own sites randomly to avoid selection bias as best we can. And once the data is collected, we want to develop an IT system to store and share the data in our inventory easily. Otherwise, it would be a lot of wasted effort and resources, so we want to, of course, avoid that. At this point in time, we've collected our site information, and then this fall and winter, I plan on collecting information from other researchers to add to the inventory, as well as develop that IT framework that will be critical for communicating our data. So the first step in sampling random forested wetlands was, of course, finding them. And to do this, I used several different map layers and the GIS software. I extracted treed peatlands and treed swamps from the Nova Scotia Land Cover Ecosystem Classification map layer, and then overlaid these with swamps from the Nova Scotia Wetland Inventory. So areas that corresponded as forested wetlands on both maps were then assigned a number, and after that I generated some random numbers, and the sites that corresponded to those random numbers that I generated were the sites that I visited, and if they were forested wetlands, sampled. So after getting out for this field season, this spring and summer, I can say that about 3/4 of the sites we visited were a forested wetland at the exact point we placed in each polygon, and I consider this a major success. It's always nice to have some online maps that fairly roughly represent the areas we go out to visit. So as you can see from our map of forested wetland sites in our inventory, we have a fairly widespread distribution across southwest Nova Scotia, which is exactly what we were hoping to achieve. Once we arrived at a site and confirmed that it was a forested wetland, we began our sampling protocol by placing a 20-meter squared quadrat in the forested wetland to represent the typical vegetation and community that we saw. And between June and mid-July, we placed the remote acoustic recorders called Audio Moss at our sites for between 7 and 10 days, depending on the weather, to record in the morning and the evening for roughly 3 hours a day, and this was to record bird and amphibian calls. We then recorded the vegetation in all canopy layers with their cover class and identified invasive species in our 20-meter squared quadrat. And additionally, we recorded the human impact in and around the wetland. So this included notes on forestry activities happening, roadways, as well as agriculture. And of course, we identified soil and surface water conditions. Our soil analysis was based on Nova Scotia's Forest Ecosystem Classification soil type and texture guides. And we also made notes about the site's slope, the topographic position, soil drainage, and moisture class, as described by the Nova Scotia FEC. And finally, we measured the abundance of snags and coarse woody debris in our sampling site. So at this point in this project, I have just started analyzing the data that I collected this summer, but so far I have a few preliminary results that I'm happy to share, and if you have any questions, you can shoot me an email at the end. So here again, you can see the map showing our inventory sites across southwest Nova Scotia. In total, we sampled 36 sites. 6 of them had the invasive species glossy buckthorn, 9 were in a protected area, and 7 had been harvested, although none of it was recent. These were old clear cuts that had already regenerated quite significantly. So these two figures show the main tree species composition of our sites, and as you can see from the top diagram, the majority of our sites were either red maple dominated or had red maple co-dominating with the other species. And I just want to make note that the mixed wood category that you see in the first top chart is not a traditional mixed wood definition as described by something like the FEC. So these were sites that had no clear dominant species, um, and so were either co-dominated by two or more species, and then the second figure, or the bottom figure, is the one that breaks down this mixed wood definition. So altogether, I don't think you can see my cursor. Just a moment. Maybe now. I can't really tell with the recording. But so this portion of the pie chart shows the sites. We had about 20 sites that were red maple dominated, and then we had 11 sites that were mixed wood. And of these 11 sites, you can see that quite a few had a red maple component in their forest canopy. These two figures show the forest successional stage of our sites, as well as the number of snags per plot. I determined successional stage using the Nova Scotia FEC, but for a significant amount of sites, a veg type could not be determined because it did not fit any of the categories well, and so they were unclassified. And this is likely due to the FEC guide being mostly developed primarily for upland forest sites. But as you can see here, a majority of our sites were in early to middle stage of succession and had varying amounts of snags. So next, looking at the soil composition of our sites, we can see that the majority were FEC soil type 14, which is an organic matter dominated soil profile, and it's very characteristic of wetlands. So we're not at all surprised to see this. But some of our sites also had soil type 3, 4, and 7. 3 is a moist, coarse, loamy soil. 4 is a wet, coarse, loamy soil, and 7 is a wet, fine, loamy soil. So there's a bit of different textures happening, even though a majority of our sites are vastly dominated by organic matter accumulation. So next I want to talk a little bit about the recordings that we took with our audio moths. And our fleet of audio moths collected about 250 gigabytes of data. If I were to sit down and listen to these recordings, it would take me 45 days without any breaks. So my current plan is to outsource some of this analysis to robots. And to do this, I want to use BirdNet Analyzer and then take random samples of the results and check them for validity. So for anyone unaware, BirdNet is an artificial intelligence neural network that analyzes the spectrograms, and you can see an example of spectrograms down here. So they're basically graphs of recordings. And this software has been trained using the Cornell Lab of Ornithology datasets and was developed by Dr. Lisa Yang, Center for Conservation Bioacoustics. This weekend, just before the conference, I was playing around with the software for the first time, and I went through the audio data of one of my sites, and we will go through that in the next slide. So on this slide, you can see some preliminary results from my first attempt at analyzing one of my site's data using this artificial neural network. And it basically spits out a list of bird species that it reported hearing. And next to it is the confidence of each identification. And so you can see there's a good mix of some wetland-associated bird species here, but also others that we would more typically associate with drier upland forests. And that's likely due to the fact that the site that this data is coming from was quite a small wetland. It was quite narrow, and it was also adjacent to a much more open wetland, as well as a lake in a nearby area, and there was a major highway probably just over 100 meters away, maybe 150 meters away. So it's really telling us not just what's going on in the wetland, but the wider community. So within the next few months, my plan is to finish incorporating the field data that I collected this summer, finish analyzing the audio data from the audio moths, and produce a report of our sites. I will then meet with the KCC Forested Wetland Group, review everything that we've done and our plans, and make changes as appropriate. We will also decide on the final storage place for our wetland database so that it can easily be shared with the research community. While we are finishing things up with the forested wetland site inventory, we will also begin discussions with the KCC group to begin designing our forested wetland monitoring program. So now, at this current point, we're at the very early stages of designing this project, and it looks more like my Christmas wish list than a functional project, but there are a few things we would like to incorporate at this point. The first is quite obvious. We want to understand how the wildlife community is changing over time in these forested wetlands, and we also want to have a focus on the insect community, which, as many of us know, form the basis for many food webs, both terrestrial and aquatic. And of course, we know that weather patterns in the province are going to shift over the coming century, but what does that mean for forested wetlands? So another major priority of our monitoring program is to monitor weather conditions in the site and link that with any changes that we see in species or site conditions. And regarding site conditions, we want to be able to monitor the water table because water is a critical component of wetland ecosystems, as well as potentially the humidity, which is important for different organisms such as lichens. And we also want to keep an eye on the extent of the wetland to see if it's shrinking or growing over time. So just before I wrap up this presentation, I want to leave you with a little bit of the importance of forested wetlands as well as wetlands in general. It's really hard to overstate their value to both human society as well as wildlife. They benefit human society in numerous ways, including preventing both flooding and droughts. They improve water quality, they cool the local weather around them, and they store carbon. And it's estimated that each year they provide about $9 billion in services to Nova Scotia's economy, which is just astounding. And of course, they're also incredibly important for many species of wildlife, including all of the province's at-risk lichens, many rare and at-risk plants, several at-risk birds, and of course, our mainland moose. They're also incredibly beautiful places from a personal sense, and they have a value that goes beyond human appreciation. And we know from our discussions with researchers that studying forested wetlands can be difficult given their diversity and complexity, and we are directly tackling a major issue in the research community with our inventory, and that's reliably finding appropriate sites for researchers' needs. It's also clear that forested wetlands are going to change over the next few decades and beyond because of major disturbances from climate change and invasive species. So having a robust monitoring system in place allows us to see those changes, make better predictions, and it's the first step in potentially remediating the damage that human society is causing. So with all of that said, I would like to thank the Kespukwitk Conservation Collaborative and Environment and Climate Change Canada for their support and funding for our work, and of course all the amazing staff at the Tobeatic Research Institute for keeping me going. And if you have any questions, feel free to email me at the email you see here. I'd be happy to have a chat with you about wetlands. Thank you. I hope you enjoyed.